So this is Leetcode number 931, which is minimum falling path sum. First of all, I would like to clarify you that the Leetcode number minimum path sum, which is of numbering 64 and this 931. First of all, they are not same, looking like a similar, but there is a very main difference between them. Like in our previous video, we see in Leetcode number 65, there is a fixed endpoint and fixed starting point. So but don't confuse this with the Leetcode number 931. It is totally different. So like now focusing what's given in the question there. First of all, we have given an n cross n matrix there, and like afterward what is given in here it is a definition of the falling path. What is it? A falling path is it starts from the any of the element in the first row and moves to the last of row to the any of element of the last row. And what are the allowed moves here? We can go in either down direction, either in down left, or either in down right. Okay, so example, if I'm saying about this test case, so here one of the falling path is like 157 there, or 148, like, or many 257 or 13. So there are so many of the falling paths, but we have to return that falling path in which the sum of it has a minimum of among all of the falling path. So that is the, so among all of the falling paths, the only this highlighted, like sum of it as a 13, and either if we take this falling path also, so its sum also 13. So this is the minimum sum. So that's why, so basically what we have to do, we have to return simply minimum sum of the any of the falling path sum through this matrix. And like we have to start from any of the element from this first row and ending at the any of the element in the last row there. Okay, now what's the observation behind this? We see one thing, like from every of the cell we have the three choices, either goes to down and this diagonal and this diagonal. So what it suggests to us, like whenever we have to many of the choices at our one cell there, so means we should go for the recursion. And after it we have to check whether by applying whether it is accepted or not, and like how to optimize that part. Okay, so do that in later. So let since this is a recursion, so first of all I have to define what is like how to do recursion here. Let's erase this part here. Okay, so first of all I have to define f function f there. So what's the meaning of my f? So wait a second here. I have to remove that part. Okay, so text is selected here. Now this is here, it is a row comma column here, and it is basically it's give me the minimum falling path sum from row comma column to what it means here, to the, we can say, the bottom row. Okay, so this is the definition of my falling. Now I have to define, and like what our goal, so what we have to find here, we have to simply find the minimum of what here, it is a 0, 0 either, or it is 0, 1, or either this goes and so on. And similarly we have to find like what are the minimum here, and -1. Okay, so what it means, like you know very well, like I have to define a row comma column means we have to start from that row comma column to the bottom row. And there are, if we have to start from the 0th cell, like 0, 0 cell, then 0, 0, so what are the minimum from that all any of the cell, we have to return that part also. So like this is our goal here. So like not now what we have to do, if you have to running this part, what are the moments, or what are the three options we have? If we have, let's say we have stand at the row comma column, so what are the possible moments here? Either we can go to down there, either we can go to left or diagonal there, or either we have to go to, wait a second. Okay, so either we have to go to the left diagonal, Left diagonal means I have to talk about the bottom diagonal, so left down diagonal there, or either we have to go to right diagonal. And like if row comma column, so how it becomes, so it becomes simply row plus 1 comma column. So that is our and how's the uh, left diagonal there, so it is nothing but the, and how's our right column there, so it is row plus 1 there and column plus 1 there. Okay, so these are the only three movements possible in the question here. And we can say one thing there, like how is our final destination, or like how is this recurrence become. So it simply become, let's have to define the met, I have to use met function, matrix there given in the question, whatever the name we can choose here. And after it we have to choose, like we have to store that current value, and now after it we have to call for further values. And like how do we do this, we can either call to this, or either we can call to row plus 1 comma column minus 1 there, or either we have to call for row plus 1 comma column plus 1. Wait a second, I'm just write the, okay. So these only these, so here I have to store the correct current value, and now I have to call for the whatever the minimum in this. So and also we can discuss here what are the base case. So whenever we have to reach to last row there, last row any of the column there, so that we have to simply store that value here. In that case we have to store that last row and the column here. Okay, so this is like now after to simply define our have to draw the dry run here. So see here, this is, let's have to discuss about the matrix number. Wait a second, let's say we have a matrix of 2 cross 2 in which the elements are accordingly to 2 1 and 3 4. Now make a recursive tree for this. So okay, like now we have to start from the f of 0 comma 0. So this is simply the f of 0 comma 0 there, and after it have to three directions, either it goes to below, either it goes to there, or either it goes to here. So it is, if we have to start from this 0 comma 0, so what are the given here, so here it is f of 1 comma 0 there. Okay, and this is for the, like I have to for better understanding I have to say this. And now here what we have 1 comma 0 there, and here we can say the 1 comma 1 here. Okay, so like you can be understandable here. This is for the down, this is for the left diagonal, this is for the right diagonal. Okay, so let's say we have to start from this, so either go to this or this or this. Okay, like this is for the f of 0 0, and let's say if we have to start from the, similarly this trace goes to tail until it reach to the base case there. And similarly we can draw from the any of the other cell here, if we have to start from the 0 comma 1 1. So what are the possible movements there, so either we go to the here, or either we go to here, or either we go to left diagonal there. So let's say, so f of 1 comma 1 there, or 1 comma 0 there, 1 comma 1 there, or we can say the f of 1 comma 2 there. So these are the similarly what are the elements in the first row we have to start, whether now what are the answer we get from here or we get from here. So what are the minimum, we simply return that value. Okay, now we see one thing there, when we have to see this f of 1 comma 0 and this f of 1 comma 0, this repeated twice. Similarly this f of 1 comma 1 and this f of 1 comma 1, this repeated twice. So this means we see the overlapping subproblems here, and like to now calculate each time, every time repeat. So to avoid this recomputation we have to store that values. And how to do, so we simply use the dp vector for storing. So that is our over dry run for this. Like now we see what is the brute force there. Okay, so here simply the code for this. First of all, this is the main function here where I initialize it, define its size there with a matrix as a input given here. Now since we have to return what are the minimum among all of the elements in the first row, so let's say we initialize our result answer into max with maximum, and we have to find what are the minimum possible among all. So column 0 to n loop goes on, and there's we have to store sol of 0 comma column, then sol of 0 comma call 0, call 1, call 2. Like here it is for the row, it is for a column, and since row is a fix, and what are the answers we have to get from that all of the elements, or we can say the all of the cells present in our first row, our starting row. Whatever the answer we get, we simply return that value. And now we have to define what's the definition of this solve function. So here pass simple the row and simple column here, and like again I use the intent there. Now this is for the whenever if I have to go exceeding the boundary of the this matrix there. So either in the case in the we have to like let's say whenever we have to go to 1 comma minus 1 means when we have to start to 2, and when we go to left diagonal, so this exceeding the boundary of the our matrix there. So in case to avoid that part, since we have to take the minimum, so to skip that cell there, we simply return the int max value so that it can be skippable now comparable to all of the values. So this is for the handling of the all of the edge cases there. And now this is for the destination when we have to reach to end of the cell, so that is our desired value, or that is our desired cell there. So in case you have to return simply that value, what are the three options there: down, left diagonal, right diagonal, and for each row column we simply store that value in our path sum there and return what are the minimum here. So this is the brute force there. Now here it is since this is a brute force there, since total number of cell is an n and each cell has a 3 options, so what is the time complexity simply here? So it is nothing but the of 3 power n there. And what is the space complexity here? So it is nothing but the recursion stack. Okay, so this is the of n for recursion stack there, because we don't use any of the extra space there, we simply calling for this recursion, and in the worst condition it has to traverse all of the cells, so that's why of n there. Okay, but like this is exponential time complexity, so it gives a TLE, so that's why we have to go for the DP, and DP we should call for the first of all memoize. So what is the memoization? This code is again the same. First we initialize our DP vector with all of the minus ones there, n cross n there, as like given in the input also, and this is code part is also same. And now we have to pass the DP in our main function, and this definition is also remain same. We pass the DP here, and here we have to check whether its value is already stored or not, so that's why this condition here, and pass simply DP in all of these value, and now this value is stored in DP and return that value there. So this is memoization version. And now we can further optimize this, but we can't go for this is also acceptable, but for the interview purpose, that's why we have to avoid that tabulation part or space optimize. So first of all, what is the time complexity for this? So this time complexity is nothing but the of the traversing along this DP vector, so that's why of n square there. And what is the space complexity here? So it is nothing but the of n of the square there. And this is for the using of the our DP vector, and again another of the for the recursion stack there. So that is our the time complexity and space complexity. So that's our question. Thank you.